Hi everyone, myself Jyoti Prasad. Today I am going to discuss about design of fast adders. Before going to see about design of fast adders, first the previous type of adders called ripple carry adder, how it will perform and what are the drawbacks in the ripple carry adder. First we will check about that and we will enter into the fast adder. So in the ripple carry adder of n bit, each bit will have one full adder. So if 4 bit means 4 full adders will be there. In the first stage, X, Y are the inputs. C is the carry, initial carry 0. So by taking three inputs X, Y, Z, it will perform full addition and gives a sum as the output S naught bit, which will be a least significant bit. And the first stage full adder output carry is given to the input of the second full adder. Then the second full adder will take X1, Y1, C1 as a input and performs the full addition, full adder addition. Output will be S1 and C1. The C1 will be the input for the next third stage. Likewise, it will carry the operation. The last stage will be the most significant bit. So here the addition, full addition will be carried out normally, but only drawback is the second stage adder or second full adder has to wait for the carry one, which is coming for after completing the full addition of first stage. So the third one has to wait for the second stage. So likewise, it is performing in a serial order, and if we have n bits after n cycles or n time, each full ladder is taking one second, then it will take n seconds to perform or to get the output, final output. This is having much of the delay. To avoid this one, we need to go for the next type of adders. Okay, so before going to tell about adders, in the ripple adder we can do addition and subtraction together using XOR gates. So one of the input we are giving the, for example, if I want to perform x minus y, x is given as it is, minus y will be taken as 2's complement, x plus y we will do an addition, we will get the answer x minus y, the resultant. How the two's complement addition is performed means using XOR gate. One of the input I am giving for the XOR gate is a y, whatever the minus y, the y bit I am giving. The second input for the XOR gate is a control bit. Here, if at all addition I am performing, the second operand I will give here. Addition means I am going to give equal to 0. Control bit equal to 0. If I give control bit equal to 1, for all the XOR gates, input will be 1. Then another input will be complemented. Complemented. I mean the ones complement will be done. If control bit is equal to 1, these XOR gates will perform ones complement. Then if we wanted to get 2's complement, we should add 1 to that ones complement. That will be done by C naught. So the control bit I am giving as a C naught here. So if I add 1 to that particular thing, one's complement, it will become as a 2's complement. So one end we are giving 2's complement, other end I am giving x. X plus 2's complement of y performs a x minus y operation. This is a subtraction using ripple carry error. So this will also will contain the delay. So that's why we are going for fast adders. So what I said, the same thing has been explained here. So design of fast adder. Due to the previous drawback, we are going to design fast adder. The first type is carry look ahead addition. Carry look ahead addition is nothing but a fast adder circuit must speed up generation of carry signal. So here the first, each full adder, consider a full adder, it will have a sum and a carry. The sum will be produced by this operation XOR gates. The carry will be produced by XY, XC, and YICI. So this carry, if I get independently, so previously C1 is given to second stage, C2 is given to third stage. So not like that. We will get, if we get all the carries of stages independently, not depending upon the previous one, they are independent, made independent, then we will get fast addition. So for doing that, the carry equation I am making that last two terms common, ci I am making common. So if we can rewrite this one as xi yi as generator bit gi xi plus yi, the which term we made common, ci common, after the left out term xi yi I am xi plus yi I am writing as pi. Pi means propagation, generation, propagation. So using this type of concept, we are calculating the carries without depending upon the previous carry. How how means we are going to show the equations. Before going to show the carry calculation equations, we need to implement three input XR gate using two input XR gates. So in the laboratory we might have seen two input XR gates, but if a XR gate is three input, so then how to carry out the three input XR gate but with existing two input XR gate means that is explained here in this bit stage cell. So, like I said, 4-bit adder carries can be implemented using the earlier equation I said, generation and propagation bits. C1 will have G0 plus P0 C0. C2 will have G1 plus P1 G0 plus P1 P0 C0. If we see any equation in this 4, C1 is depending on C0 only. C2 is depending on C0 only, but not C1. See, in the second equation, we have not seen any C1 here. It's purely depending upon C0, which is getting it at a input stage. No need to depend. That's a input, common input. If I see C3 equation also, G2, P2, G1, P2, P1, G0, P2, P1, P0, C0. So C3 equation depend upon C0 parity, propagate generate bits only. It is not at all depending upon previous stage carry. So we made by using this equation generation propagation bits, we made four carries independent together. So here the bit stage cell, what I have shown here is called B cell. X naught Y naught first stage input we will give. S naught is the output by taking C naught as a third input. It will generate also along after some it will generate G naught P naught whatever in the carries that is given to a logic called these four equations is kept in this box named with carry look ahead logic. So this will calculate and give the intermediate partial products. So the second stage where it is taking carry look ahead logic, it is taking from carry look ahead logic. So this will give the required propagate bit generate bit c naught already existing. So with this, when the first stage is happening, the second stage will happen, the third stage will happen, fourth stage will also happen parallelly, and there is no case of delay or waiting for the first stage finish or waiting for the second stage to finish to carry on third. So the things is it can be done be parallelly using carry look ahead logic. So that's why it is called as fast adder. Thank you so much.